In this video, we are going to talk about differentiation of function. Uh, First, we'll look at the prior knowledge, what we have learned earlier on differentiation, the basic or the standard differentiation rules. The first one, derivative of x raised to n. If the function looks like x raised to n, like x raised to 7 or x raised to 15, x cubed, so x raised to n. The derivative is n times x raised to n minus 1. So the derivative of x raised to 4 would be 4 times x raised to 4 minus 1, which is 3. So derivative of x raised to 8 would be 8 times x raised to 7, 8 minus 1. Root x, for example, would be, you will read it as root x, you would read it as x raised to half and then half into x raised to half minus 1. So I'm going to write one or two results based on this. This is derivative of k times x. K is a coefficient, so it stays there, and derivative of x is 1. How is it 1? Because it is x to the power of 1. So when I apply the same rule, x to the power of 1 would be 1 into x raised to 1 minus 1, 0. X raised to 0 is 1. So derivative of x is 1. So k into 1 is equal to k. That's the second rule. So one more time, x raised to n becomes n times x raised to n minus 1. Derivative of kx is k times 1, which is k. Derivative of 5x would be 5. Derivative of 7x would be 7. Derivative of 10x would be 10. The third result, derivative of a constant. Derivative of a constant is going to be 0. Derivative of 8 would be 0. Derivative of negative 3 would be 0. Derivative of any constant is 0. So there is a difference between the k, which I talk about in this question, derivative of kx. There k acts as a coefficient. So it stays there into 1, which is the derivative of x there. While this is a constant term, and so the derivative is 0. The fourth result, derivative of 1 by x. It's minus 1 by x square. In fact, this is like, if it's good to remember the result, but otherwise you will write it as x to the power of minus 1. That's your question. And then it falls under the first type. So x to the power of minus 1 derivative would be minus 1 into x raised to minus 1 minus 1, which is minus 2, which I moved to the denominator. So it becomes minus 1 by x square. So derivative of 1 over x is minus 1 over x square. Derivative of 1 by x minus 1 by x square. The fifth result, derivative of root x is 1 over 2 root x. That's again x raised to half, you write and do it. So x raised to half, and that's how you do it. So root x derivative is 1 over 2 root x. The sixth result, derivative of sin x is cos x. Derivative of cos x is negative sin x. Derivative of tan x is secant square x. Derivative of cot x is minus cosecant square x. Derivative of sec x is sec x into tan x. The next one is derivative of cosec x is minus cosec x cot x. So the 6 trigonometry functions here, derivative of sin x is cos x, derivative of cos x. Derivative of all the co-functions are negative. If you see, that's a way to remember it. Derivative of sin x is cos x, derivative of its co-function is negative sin x. Derivative of tan x is secant square x. Derivative of the corresponding co-function, cotangent, is negative cosec square x. Derivative of secant is sec x tan x. Derivative of co-function cosec x is negative cosec x cot x. Derivative of e raised to x is e raised to x itself. Derivative of a raised to x is a raised to x into log a. But remember, when I say log a, under calculus, wherever we talk about logarithm, it's supposed to be natural logarithm to the base of e. So if I don't write any base under So from the context you will know. Under calculus, you will treat this as logarithm to the base of e. That's like ln a. So derivative of a raised to x is a raised to x into, some people write it as ln a. But when we write it as log a, the base is assumed as e because it is under calculus. Derivative of log x, again it is ln x. It is log x to the base of e, you should remember. The derivative is 1 by x. Derivative of log x to the base of e is 1 by x. You may not write that either. Derivative of log x is 1 by x. Derivative of, this is another way of writing it. Log x to the base of e is written as ln x, which is 1 by x. So here again, this log a is actually with base e. So those are the standard results. Now we talk about function of a function, a composite function, function of a function. And the method in which we differentiate this is also called chain rule. So we look at this function of a function differentiation here. This is the first function here. This is like y is equal to x raised to n. But instead of x, I will have a function of x there. Y is equal to f of x the whole raised to n. Now, how do we differentiate x raised to n? X raised to n is n into x raised to n minus 1. So something to the power of n would be n into that raised to n minus 1. But it's not finished. You should times it by the derivative of the inside function, which is f of x. So the derivative of y is equal to f of x the whole raised to n would be, it is similar to x raised to n. So it should be n into x raised to n minus 1. So in this case, it would be dy by dx would be n into f of x raised to n minus 1, and then times by the inside function, which is the inside function f of x, times by f dash of x. And things will be more clear when we start doing the questions. This is y is equal to 1 over f of x. That's similar to 1 over x, but instead of x, I have a function. What's the derivative of 1 over x? If you go back and look at the result, you will see 1 over x is minus 1 over x square. So what is dy by dx here? 1 over x is minus 1 by x square. So 1 over f of x would be minus 1 by f of x the whole square. 1 over x is minus 1 by x square. 1 over f of x is minus 1 by f of x the whole square, but times by the inside function derivative. Third one, y is equal to root of f of x. This is similar to y is equal to root of x. What's the derivative of y is equal to root x? Y is equal to root x, derivative is 1 over 2 root x. So y is equal to root of f of x would be 1 over 2 root f of x and times by f dash of x. Next, y is equal to sine of f of x. What's the derivative of sine x? Sine x is cos x. So sine of f of x would be cos of f of x, and not finished, into the inner derivative f dash of x. So sine x becomes cos x. So sine of something becomes cos of the same thing, cos of f of x. You don't even see what it is. It's sine of something, f of x, is cos of the same thing, f of x, but times by its derivative, times by the derivative of the inside function f of x. Y is equal to cos of f of x. So what does that look like? Y is equal to cos x. And what's the derivative of y is equal to cos x? Y is equal to cos x is, derivative is negative sine of f of x. Derivative of cos x is negative sine x. So derivative of cos of f of x would be minus sine of f of x, but not finished, into f dash of x. Y is equal to tan of f of x. What's the derivative of tan of x? Tan x. Tan x is secant square x. So what would be tan of f of x? Secant square of f of x into f dash of x. Next is y is equal to sec of f of x. And the derivative of sec x is sec x tan x. So what's the derivative of sec of f of x going to be? Sec of f of x would be sec of f of x tan of f of x into f dash of x. One more time. Sec x would be sec x tan x. So sec of anything would be sec that into tan that into the derivative of the inside function. So sec f of x is sec f of x tan f of x into f dash of x. Y is equal to cosec f of x. Cosec f of x. So its derivative would be cosec x. What's the derivative of cosec x? Cosec x is minus cosec x cot x. So this would be minus cosec f of x cot f of x into f dash of x. Y is equal to e raised to f of x. This is similar to e raised to x. And what's the derivative of e raised to x? Derivative of e raised to x is e raised to x itself. So what should be the derivative of e raised to f of x? Would be e raised to f of x itself, but times by f dash of x. Y is equal to natural log of f of x. Natural log of f of x. Log of f of x to the base of e. We might not write this e all the time. So log of f of x. Derivative will be dy by dx will be 1 by f of x because log x is 1 over x. So log of f of x is 1 by f of x into f dash of x. Now we start with differentiation of function of a function based on the rules we discussed. So here we have the question, differentiate with respect to x. The first question here, y is equal to sine of x square plus 5. So what does it look like? It looks like y is equal to sine of some function here. It's not x. If it was sine x, I would have directly written it as cos x. But this is not sine x. Instead of x, I have a function of x written here. So I will read it as y is equal to sine of f of x. How would I differentiate sine of f of x? Sine of f of x would be cos of f of x, but times by f dash of x. So if we come back here and try to differentiate it, y is equal to sine of f of x. The answer has to be cos of f of x and times by f dash of x. So let's try that. Dy by dx will be cos of f of x. F of x is x square plus 5. And times by f dash of x, derivative of the inside function. What is your inside function? It's x square plus 5. So its derivative is 2x. So times it by 2x. I have another question for you to try on your own. So you could probably pause the video and try to differentiate this. And then we move on to the next question. Y is equal to tan of 3x square minus 7. And again I see if it was tan x, simple x, tan x is secant square x, sec square x. Tan x is sec square x, but it's not x. It's a function of x. So how do I read it? I read it as y is equal to tan of f of x. So what's the derivative of tan of f of x? Tan of f of x would be sec square of f of x and times by f dash of x. So when I come back and try to differentiate this, tan of f of x, tan of 3x square minus 7 would be secant square of 3x square minus 7. Tan of f of x became sec square of f of x. So I don't even see what it is actually. I just read it as tan of f of x becomes secant square of f of x. But then times by the inner derivative. Derivative of the inside function. What's the derivative of 3x square minus 7? 3x square is 6x. 3 times 2x, 6x. Minus 7 is 0. So I don't write that. So it is just 6x times by the inside derivative. And here is your question. Y is equal to cosec of 3 minus 2x raised to 4. You should try that on your own. And then we move on to question 5. Y is equal to cosec of e raised to x. If it is cosec x, simple x, I know it is minus cosec x cot x. You should go back and look at the result. So cosec x is minus cosec x cot x. But it's not x. It is cosec of f of x. And so its derivative will be minus cosec f of x cot f of x into f dash of x. So when I differentiate this, Cosec of e raised to x would be minus cosec e raised to x cot e raised to x, and not finish into the inside derivative. Inside function is e raised to x, so I multiply by the derivative of the inside function, which is e raised to x. Here is your question. Y is equal to e raised to sine x. And then we are going to look at question 7. Y is equal to log of sine x. Log x, if it is just log x, what's the derivative of log x? Log x is 1 over x. Of course, you should remember that the base is e. Log x is 1 over x. So log of f of x would be 1 over f of x, but times by f dash of x. So coming back to the original question, log of sine x would be 1 by sine x into the inside derivative. Sine x derivative is cos x. Log of sine x, log of f of x, 1 by f of x, log of sine x, 1 by sine x, but times by the inside derivative. Derivative of sine x is cos x, and now cos x by sine x will change to cot x, which I haven't written there. And here is your question. Y is equal to log of x cubed plus 3. Looking at another question, y is equal to log x to the power of 4. This looks like x raised to 4, and x raised to 4 would have been 4x cubed. So log of x the whole raised to 4 would be considered as y is equal to f of x raised to 4, f of x raised to 4. And f of x the whole raised to 4, when I differentiate, it becomes 4 times f of x the whole cubed into f dash of x. So what would happen to log x to the power of 4? In the same pattern, 4 times log x to the power of 3 into derivative of log x, which is 1 by x. So dy by dx is 4 times log x to the power of 3 into derivative of log x is 1 by x. That's your question. Y is equal to e raised to x square minus 5x. Look at the next question. Y is equal to log of log x. Isn't that again like log of x? Log of x is 1 over x. So what is log of f of x? 1 by f of x into f dash of x. Log of f of x would be 1 by f of x, like 1 by x, 1 by f of x into f dash of x. So log of log x would be, derivative would be 1 by log x into f dash of x, derivative of the inside function, which is 1 over x. That's your question. And what we are going to do is y is equal to sine of x square. Sine of x square looks like sine of f of x. If it was just sine x, the derivative would have been cos x. So sine of f of x, when I say its derivative would be cos of f of x into f dash of x. So what's the derivative of sine of x square? Cos of x square into f dash of x, derivative of x square, which is 2x. Of course, I rearrange it like 2x times cos of x square. Here is your question, and this is what we are going to consider. Y is equal to sine square x. Whenever we write sine square x, the meaning of it is sine x the whole square. And the moment I consider it that way, it looks like x squared to me. And the derivative of x square is 2x. But it's not x, it's f of x. So this is to be considered like f of x the whole square. And what's the derivative of f of x the whole square? 2 times f of x times by f dash of x. So when I come back and differentiate this, dy by dx would be 2 times sine x into f dash of x. Derivative of the inside function is cos x. Another question for you to try. Y is equal to cot cubed x, but you should rewrite this cot cubed x as cot x the whole cubed, and then try to differentiate it. This is our question here. Y is equal to cot cubed of 7x minus 2. So I'm going to rewrite it as cot of 7x minus 2 the whole cubed. But you should realize that in this particular question, I have multiple functions involved. First thing is, it looks like something like x raised to n pattern. But when I look at the inside function, that looks like cot of f of x. So you will have chain rule applied twice in this. Let's try to look at this function in detail. So the original question looks like f of x the whole cubed, because I made it like cot of 7x minus 2 the whole cubed. So f of x the whole cubed is 3 times f of x the whole square into f dash of x. So something whole cubed, f of x the whole cubed, is going to be 3 times cot of 7x plus 7x minus 2 the whole square into the inside derivative. And what's the inside derivative? Cot x. Cot x is minus cosec square x. But it's cot of f of x, which will be minus cosec square of f of x, which is 7x minus 2, into still I have an f dash of x. 7x minus 2 derivative is 7. Question 37 I pick up, which is y is equal to 2 times root of cot of x square. The original question looks like 2 times root of f of x. Read it like root of f of x. Don't even see what it is. It's root of f of x. Root of f of x, when I say, it looks like root of x to me. And root x derivative is 1 over 2 root x. You should go back and look at the result. Root x is 1 over 2 root x. But I have this 2 here, which is the coefficient. And coefficient has to stay there. So this is going to be 2 times 2 coefficient stays there. And root of f of x is 1 over 2 root f of x into f dash of x. So what's the derivative here going to be? dy by dx will be 2 times, 2 will stay there coefficient. Root of f of x will be 1 over 2 root f of x. 1 over 2 root f of x into f dash of x. And what is f dash of x? Cot of x square derivative is minus cosec square of x square. Cot x is minus cosec square x. Cot of x square is minus cosec square of x square into, again, an inner function, x square becomes 2x, which is of course rearranged like that. And that's your question there. Y is equal to cos of root x. We look at question number 39, which is y is equal to e raised to root of tan x, which looks like e raised to x, and e raised to x derivative is e raised to x itself. But I'm going to read it like e raised to f of x. So e raised to f of x would be e raised to f of x itself into f dash of x. So here, when you try to differentiate it, also, why, if you have root of f of x, what would be the derivative of root of f x? When I go inside, that's what is going to happen, and that's going to be dy by dx will be 1 over 2 root f of x into f dash of x. Okay, so let's try to do this question. So e raised to f of x is e raised to f of x itself into the inner derivative. Inner derivative, when I say it, is root of f of x, and root of f of x is 1 over 2 root f of x into f dash of x. So root of tan x is 1 over 2 root tan x into secant square x. Let's try that one more time. Y is equal to e raised to root of tan x. So you will read e raised to root of tan x like f of x. What's the derivative of e raised to f of x? E raised to f of x itself. So e raised to root of tan x. E raised to root of tan x itself. But now I need to differentiate the inside function, which is not tan x, it's root tan x. So what's the derivative of root x? 1 over 2 root x. So what's the derivative of root of tan x? 1 over 2 root tan x into derivative of tan x is secant square x. That's your question, which you should try. Y is equal to sine cubed x plus cos raised to 6x. So differentiating, dy by dx will be, I read sine cubed x as sine x the whole cubed, which is 3 times sine x the whole square. Of course, I write it as sine square x. That's the meaning of it. So sine x the whole cubed became 3 times sine x the whole square, n into x raised to n minus 1. Like x cubed is 3x square. Sine x the whole cubed is 3 times sine x the whole square. into the inside function. What is the inside function? Inside function is sin x. Derivative is cos x plus cos raised to 6x, which is actually cos x the whole raised to 6. And cos x the whole raised to 6 is 6 times cos x the whole raised to 5 into the derivative of cos x, which is minus sin x, which is the answer. You should try this question yourself. And we look at a new question, y is equal to tan 2x into sine square 5x. So what is new in this question? This is y is equal to tan 2x into sine square 5x. That's a product of two different functions. We call it as u and v. You have learned this last year. So that's u times v. So I'm going to remind you, I call the first function as u, and I will differentiate it. I'll call the first function as u. U is tan 2x, and so I take its derivative, which can be also written as u dash. So what's the derivative of tan 2x? Sec square 2x into 2. And then the second function I call as v, sine square 5x, which is actually sine 5x the whole square, which is not necessary to write it. You could just read it in your head. And so derivative will be sine square 5x is 2 times sine 5x into cos 5x into 5. One more time. Sine 5x the whole square derivative is 2 times sine 5x into the inside derivative. What's the derivative of sine 5x? Sine 5x is cos 5x into 5x derivative is 5. So that's my v. So I know what is u and u dash. I know what is v and v dash. Now the product rule, dy by dx is equal to u into v dash plus v into u dash. First function into derivative of the second plus second function into derivative of the first. U into v dash plus v into u dash. I know all the values. I'm going to just plug it in. U is tan 2x into v dash. V dash, of course, we found here. I copy that. Plus v. V is the second function. Copy the second function sine square 5x here into u dash. U dash is done here already, which I copy. That's for you to try on your own. Y is equal to e raised to x into log of 1 plus x square. That's again product. E raised to x is here u, and that's here v. So u into v, product rule, u into v dash plus v into u dash. First function into derivative of the second plus second function into derivative of the first. So I write what is my u. U is e raised to x, therefore u dash is e raised to x itself. My v is log of 1 plus x square. Therefore v dash will be 1 by 1 plus x square into the inside derivative, which is 2x. Log of x is 1 over x. Log of f of x is 1 over f of x into f dash of x. So log of 1 plus x square is 1 by 1 plus x square into 2x. So dy by dx, that's my u and v. So product rule, u into v dash plus v into u dash. I just plug in all the values. Substitute the values for u and v dash plus, then I copy my v into u dash. And that's your question. And we look at cos square x into e raised to tan x. It's u into v again. So I'll write what is u. U is cos square x. So u dash would be cos square x. Something whole square is 2 times that. X square is 2x. Cos square x is 2 times cos x into negative sin x, the inside derivative. Now I copy my v, which is e raised to tan x. E raised to x derivative is e raised to x itself. E raised to f of x would be e raised to f of x itself into f dash of x. So e raised to tan x derivative will be e raised to tan x itself into secant square x. Now I go back and differentiate. That's my u and v. So the rule is u into v dash plus v into u dash. First function into derivative of the second plus second function into derivative of the first. Then plug in the values. Put the value of u, then I copy the value of v dash from there. That's my v dash, I copied there, plus then v, I copy my v, the second function, and u dash is out there, which I copy here. That's a question for you. You should pause the video, try it on your own, and practice. Here's another question. Y is equal to 5 root x into cos square x cubed. So u is the first function, which is 5 root x. 5 root x derivative. 5 is the coefficient, into root x is 1 over 2 root x. So that's u. Therefore, u dash is this. V is cos square of x cubed. Cos square of x cubed is like cos x cubed the whole square. So I need to read it like f of x the whole square will be 2 times f of x into f dash of x. So 2 times cos of x cubed into cos of x cubed will be minus sine of x cubed into x cubed will be 3x square. So how does it go, you see? So since I read it as cos of x cubed the whole square, first it will become 2 times cos of x cubed. Now cos of x cubed will be minus sine of x cubed into x cubed becomes 3x square. So I have u and u dash. I have v and v dash. Everything is done. So I go back and differentiate. Of course, I rearrange this like 3x square into 2 and minus is minus 6x square, and then cos of x cubed into sine of x cubed. So I write dy by dx is equal to u into v dash plus v into u dash and plug in the values. Copy the value of u 5 root x into v dash. V dash is this whole thing I copy. Then I put plus v. V is the second function, cos square of x cubed, into u dash is from there 5 by 2 root x. That's a question for you to try. This is a special question. Y is equal to log of log x to the base of 7. Log of log x to the base of 7. Now, this is a problem for us. Until now, we said, see, like in the homework question, you see, it's written log of 3x. And if no base is written, we said it's to be considered as natural log under this section, under calculus. So if no base is mentioned, we will treat it as base e natural log. While here there is a base defined, base written, which is 7. And base 7 we cannot differentiate. It has to be base e. So we have something called a base changing rule. Log a to the base of b is log a to the base of c. You introduce any new base you like divided by log b to the base of c. So log a to the base of b is log a by log b to the new base, whatever you like. So I could also write it with base e, log a to the base of e by log b to the base of e, which is ln a by ln b. So here the base is not 7. So what I'm going to do is log a to the base of b, I'll write as log a by log b, of course base e, log a by log b. So this is going to be log of log x by log 7. Log of log x, that's my log a, by log b. Log b is log 7 to the base of e. But I know that we don't often write that e, so not to confuse you, I remove that e from there. So when I try to differentiate now, this 1 by log 7 is the coefficient which will stay there. So 1 by log 7 I write into log of log x. Log x is 1 over x. So log of f of x is 1 over f of x into f dash of x. So log of log x is 1 over log x into 1 by x. This is now quotient rule, u by v, and you know the quotient rule. I need to call the numerator as u and the denominator as v, so I copy what is u. U is cos x, so u dash is minus sin x. V is the denominator, log x, so v dash is 1 over x. Now we try to differentiate. Dy by dx is, that's a quotient rule, you have learned it last year. So I write the formula straight away. V into denominator into v into u dash du minus u into v dash dv by v square. Denominator into, you start with the denominator. Denominator into derivative of the numerator minus numerator into derivative of the numerator into derivative of the denominator by denominator square. One more time, denominator into v into u dash, which is derivative of the numerator, minus numerator into derivative of the denominator by denominator square, v square. V into u dash minus u into v dash by v square. I got everything already set here, so sub in all those values. V is log x into u dash is minus sin x, minus numerator cos x into derivative of the denominator 1 by x by denominator square, which is your answer. Of course, you can rearrange it a bit there, so that's what I'm doing there. That's your question for your practice. And we look at sine of ax plus b by cos of cx plus d. I call the numerator as u and the denominator as v. Write what is u sine of ax plus b. Therefore, u dash will be cos of ax plus b times a. Denominator is v cos of cx plus d. So, v dash would be cos x derivatives minus sin x. So, cos of cx plus d is minus sine of cx plus d into c. So, dy by dx is v into u dash minus u into v dash by v square. U and u dash, v and v dash, everything is ready with us, sub it in. So, v into u dash minus u into v dash by v squared. This is for homework. And we look at this question, x square divided by cos of x square plus 1. So that's again quotient rule. It looks like u by v, so quotient rule. So I write what is u. U is x square, so u dash is 2x. V is the denominator, cos of x square plus 1. V dash will be cos x will be minus sin x. So cos of x square plus 1 will be minus sin of x square plus 1 into f dash of x. Cos of f of x minus sine of f of x into f dash of x. So minus sine of x square plus 1 into 2x. Now we write the quotient rule, v into u dash minus u into v dash by v square. Denominator into derivative of the numerator minus numerator into derivative of the denominator by square of the denominator. I have all the values ready with me, which I am substituting. And that's going to give me the derivative here. So that's square of the denominator. Here's your question. So you need to do all these questions which I have kept for homework and practice them.